Hey guys, welcome back to the Predicta holiday restoration project. I really hope to try a first power up by the end of this installment. Got a little bit more recapping to do on the main chassis. I need to reinstall the rebuilt main board, and I need a good set of tubes. So this is definitely not a real rebuilt main board, but it does have a full set of tubes. Well, almost, minus one. So I'm going to try harvesting some from this. This is the board from the original chassis that came with this set. Some of these tubes are really hard to get out. So a little screwdriver helps. Much easier to do, of course, when the board's not in the set. And I think I can see why some of these tubes are pretty hard to get out. Look at that corrosion and gunk from all the years of sitting in that socket down in that damp environment. I think that also leads to, so not only do these original sockets use thin metal, but when they're really stuck in there and you got to keep rocking and rocking and rocking and prying to get them out, it just adds more stress to the tubes and the sockets and speeds up their demise, I think. So, also the chassis I am using came with some tubes, and I got another part set. So between the three of them, I think I got everything except maybe a 12 DQ6. Maybe because it's the biggest tube, maybe because it sees a lot of abuse in the set, being the one that powers the flyback, and there's a beam power tube, and it probably burns out sooner than the others. Well, anyways, they seem to often be broken, missing, or dead. So I think between the three sets that I'm scavenging stuff from, I still don't have a good 12 DQ6, but I'll hunt around, and if I have to, I'll pull one out of a working set. I'm working down in this area, and I noticed something a little odd, and a potential for doing a little bit of circuit modification. The original holiday chassis from the set has a terminal strip down in here with a cap and a resistor, and this cap goes over to this tie point. This guy doesn't have it. It's odd. And this lug is unused. These parts are the same though. That's what I really want to talk about right now. I'll have to check down that other part. It's probably a production run change. So, those components, or at least two of them, are here. Notice this is .0056. Both of these chassis have a .0047. Minor difference, but worth noting. 270 ohm 3 watt resistor, they both have that. And there is a decoupling cap. Actually, not decoupling, that is the cathode bypass cap on the vertical output tube. And that's the vertical linearity control. So very similar to that Siesta set. That's the control that was bad on that one. When these go out on either one of these sets, they kill it, because that is the cathode, source of cathode current on the vertical output tube. So, two things worth noting. One, this cap goes to two stakes. This stake has nothing going to it other than this cap. The modern equivalent of that cap is pretty darn small. So I bet this could be located to the board. Forget about this stake altogether. Don't know any wire going to it. If this could be put on a board and bridged between these 2 points. And I'm sure it could, because it's going to one pin 9 on this tube, and then to a cap on pin 3. The other thing is this cap was part of the, I believe it's one of these guys. This is a 3-section cap on the top side of the chassis. That cap could easily be located between L5U on the main board and ground, or that's this point right here, it's right next to it, a ground lug with nothing to it. Put that cap right here. Done. Yay, parts have arrived. I should have everything I need now to finish this off. So let's see what we got. These, I got two, just in case. I usually like to order an extra. Prices aren't too outrageous. So this is, I believe, I think it's an 18 ohm resistor rated for 17 watts. So that's where we place the current 20 ohm 10 watt resistor I got in there. Kind of an odd coating. I've never seen one that quite looked like this before. You can clearly see the resistance wire underneath that coating. What else? 100 microfarad, 200 volts. That goes, I believe it's one of the sections on that guy. I'll replace that. Oh, and I did look in the service info. This was indeed, that terminal strip that's been removed, that was indeed part of production run 4 change, I think it was. So all the component values I found in here and the wiring is all just as it should be. And I didn't find a good place on the board to mount that cathode bypass cap, so it went right there on the terminal strip. And so, in this bag, very carefully packed, we've got our more appropriate thermistors. So we will replace those two tiny thermistors in there with these guys. Similar specs, both 220 ohms at room temperature. However, being larger, these take a little bit warmer to warm up, and when they do, they have a higher on resistance. These are like 0.8 ohms at operating temperature. These are like 4.5. So two of them in series will be a lot closer to the original than these. Okay, then I got, just to kind of bulk up my stores, my supply caps, I got a bunch of 22 microfarad, 350 volt. The original were 20 ohm, 200 volt. I was a little bit surprised when I was looking for capacitor values. I thought maybe I'd get some 250s. And they don't seem to make them in that value. I think it goes 200, and then 350, and then a small selection of 400, and then a bunch of 450s. So, or I think there were a couple that were like 315. So I really wanted to get 300 volt caps, but they just didn't seem to make any, or very limited selection. So there you go. So let's supply and demand. 150 microfarad, 250 volt, I will use that to replace this guy, which is, I think, 130 microfarad at 200 volts. $140 microfarad at 200 volt. They don't really make 140s anymore, so I went with the closest value that was a little bit higher. That would be 150. And it should do it, along with the other caps I already had. So, one thing I need to do is figure out what I want to do about this guy, the power supply. So this is the one I had kind of reworked from the other sets, where I cut out the old original diodes and used this to mount the new ones. I'm not so sure I want to do that anymore. I think I might try to find a terminal strip. So I saw somebody post online a photo of a vertical terminal strip, and then it occurred to me, I think I have some of those. Let's see my little stash here, if I have any. Yeah, here's one. This. I saw somebody use one of these. I think that will work out better than trying to kind of kludge parts onto the little things up here. My goal is to get these two silicon diodes and at least two, ideally 3 filter caps. That would really help clear things up. 2 for the voltage doubler and 1 for the final filter cap after the choke down here. and I've done some more work, so I'm actually getting pretty close. There aren't all that many parts on here. I think I've got 2 more paper caps to replace. These resistors, quite a few of them are measuring off, especially these power resistors where they're 20-30% high, so I'll probably end up replacing all of them. But again, there aren't that many, so a little bit of work to do down here. Replace that guy, replace the remaining electrolytics that I haven't done yet. 1 resistor there. And yeah, boy, we're getting real close. It'll be time to reinstall the main circuit board. Now let's really dig into the heart of the power supply. So here is the dual diode module with caps across it. So this 3-legged cap, that's this guy here. These other 2 are in parallel with it. Just kind of curious. I don't think I've seen that before. These things rarely go bad, so why would they have done that? Looks like they're 22 picofarad. If I'm reading that right. And this is a 0.001. Now, I don't really think, strictly speaking, I need any of these anymore. So originally this was germanium diode. These were germanium diodes. Well, the ones in here are germanium diodes. This was early days for semiconductors. These were not the most robust devices. You can see the rating on it's only 300 milliamps. So they put those caps there, I've been told, to suppress transients of when the diodes switch on and off, because these were susceptible to it. Likewise, that's why it's mounted on this metal, is for a heatsink. Modern silicon rectifiers, like a 1N5408 rated for 3 amps, don't really need them. That's what I used when I was starting to work on the other one. But I did leave it in because it doesn't do any harm to leave it in, but you can see how it's deteriorating. But I am curious why they added these extra smaller ones. I'll have to see if that's in the service info anywhere. Because here and there you do see UHF only 0.001, UHF only 0.001. However, those 2 are not these 2. So, anyways. So I've been starting to pull out some of the wiring that we don't need anymore. This, I do believe, is the main output. I do sort of have some labels on here. So it says AC on this side and plus on the other. That corresponds to this. So AC and plus. So the AC side needs to go, or needs to have this cap, which is currently down below. Possibly I could put it up here, but I don't think I will because I got some other thoughts in mind. I might. I'll see how it goes with this little terminal strip I'm thinking of using. But I definitely want to get these 2 rectifiers up there and these 2 caps. The filter choke is directly below. You can see it down here. So that'd be a great help if I can get all these parts right here in this area. So to get at it, I'm taking this off. This is where the UHF, VHF antennas hook up and a local distance switch. Notice there's a 1/4 inch, or 2 1/4 inch sheet metal screws on there. I'm taking those out, and also let me get at this big old 56K resistor there. That's the width control. I'm hoping when I take this out, there'll be some sort of suitable mounting hole. These clip on to the chassis through these 2 spring clips. I'm hoping that I can mount something like this down in there. There's one little mystery solved. Mystery for me anyways. I've found these little bits of cardboard, fish paper, whatever this is, lying around in sets. In fact, I found one on the bottom of this cabinet. I don't know what they were. I knew there was some sort of insulating something that went somewhere. I'd never seen one still intact. That is what's supposed to keep the plate cap for the horizontal output tube from smacking or getting chafed by this. I usually replace that with a grommet, But, nice. The reason I'm looking at this at all is, now that I got this thing topside, I'm starting to clean it up a little bit. Very little corrosion, but certainly dusty. But there is definitely a lot of corrosion on the lid of this high voltage box. Inside, it's quite pristine. That's one of the nicest looking Predicta flybacks I've seen. Just some minor cracking on the wax coating. And the rest of the box isn't corroded, and the inside of the lid isn't. It's just the top. That's unfortunately it's spot welded with this metal braid, and most sets I've seen this is broken off. So that's kind of what I'm thinking of doing. Otherwise, I could take out some sheet metal screws and remove it. Oh, I suppose that's what I'll do. And then I can submerge the whole thing and remove the rust from that. There we go. I can see why these are usually missing. As soon as I applied any pressure to it, it just started to fall apart. Time has definitely taken its toll on this material. Sure, I could make a replica, but I think grommets are a little more practical. Let's see what we can do with this power supply. I made a simplified design here to aid me in putting it together. AC coming in here, other side of the AC line going to ground. One electrolytic, 2 silicon diodes, another electrolytic, filter choke, another electrolytic. Filter choke's down below. I'd like to put everything else up here. These are the parts I'm going to use. 3 electrolytics, all rated for 105 degrees Celsius, with pretty decent specs in terms of ripple handling capabilities and life expectancy. Silicon rectifiers. I've got 2 basic options here. These are both, or all of these are 1000 volt diodes. The bigger ones are rated for 3 amps, smaller ones for 1 amp. The originals, as we saw, were rated for 300 milliamps, so either one of these will work fine. These are more robust, but they're also larger, so if I can fit these in, I'll use them. If not, I don't think I'll have any issue using these. And then terminal strips. I thought maybe I'd use something like this, but then I realized that both sides of this are shorted together. So I numbered these to figure out how many points do I need that are isolated from each other. 1, 2, 3, 4 plus ground. This has 1, 2, 3 plus ground. Not going to cut it. But I could use one of these 2. Now, I'd like to reuse one of these mounting holes as well. So I could put something like this here, but then it's getting kind of close to the UHF box. Or I could flip it around this way. That certainly gives me more room, but I want to make sure I've got clearance for this guy. That gets mounted in like that, so that's pretty good distance there. And I'll be replacing this with a smaller resistor, so I think we could go with that. Otherwise, I've got this guy, which could fit in here kind of, but it's starting to bump into that resistor in the wiring. If I try the other mounting hole, it's getting pretty close to the high voltage box, so in spite of this having some nice big lugs to work with, I think I'll have to go with this guy and mount it like so. Alright, so that gives me the ground and the other 3 terminals, and that's decent spacing, so we can go literally in that order. AC going here, we put the cap from 1 to 2, the diodes between 2 and 3 in ground, ground being the 4th terminal. And then we put the last 2 caps, well, on this side and this side. So I'm just going to, without soldering, just kind of stick the parts into the lugs and kind of see physically will that arrangement work. Now there is another possibility, or a couple possibilities. Used to be one big 4-section electrolytic there, and a single big cap here. They're both gone. So you could put a terminal strip here, or over there. We've already got a couple wires here going to that, and we've got some wires here that were going to this guy. But I kind of like to keep it all condensed. So let's look at briefly how the original design was routed. AC coming in here. One side goes right to ground. The other side goes to terminal strip, then diffusible resistor, then through to the power switch, then over to this AC cap here, then to the dual rectifiers that were down there, and then to a filter cap over there, and then to the filter choke here, and then back to the final filter cap over there, and then to the main B+ distribution bus throughout here. So, with my new proposed relocation of the parts, AC in, fusible resistor, power switch, everything is right here. All 3 electrolytics, both rectifiers, filter choke, and then B+ into the set. So not only does it open up a lot of space and simplify the wiring, it keeps kind of all the hum and all the power supply stuff right over here in one little compact area. And none of this stuff generates any heat. None to speak of. And also, the cooler you can keep caps, the longer their life expectancy. Having them over here kind of away from everything else, down where the antenna terminals come in, it's kind of open to kind of air circulation where the screw terminals are, but also there isn't a whole lot going on around here. There's one really low power tube in here, then that's it. All the main heat producing stuff is kind of more over this way and over this way. There we go. I ended up kind of installing one of them on the back side a little bit, the one in the middle, and then offsetting the leads a little bit on the outer two, and there we go. Nice, neat and compact, and it will mount right there. Now, one thing I noticed on the old assembly was there was a really heavy gauge wire. Well, heavy gauge relative to the others. This is probably 18 gauge, and it's just going to the chassis. And then it was going up into that module. Well, one thing about terminal strips, if I was to attach this down with a screw and using this as the common ground point for the main power supply, that's not necessarily the greatest ground connection. If there gets to be some corrosion in there, it's not the best scenario. So what you'll sometimes see in sets with twist lock caps or terminal strips is they will have a dedicated grounding wire soldered right to the chassis and then going to a lug on the cap or a lug on a terminal strip. So I'll reuse this wire and hook it in to that ground on the terminal strip to make sure it has a really low resistance path to the whole chassis and all the circuits. So 2 diodes to mount, and then figure out which of these wires is which, and we are well on our way to being able to power this thing up. Just about done. I have one more wire to route up to this. I recycled one of the wires from down below to go from the fusible resistor holder and come around the top side over to that. So that is the AC input. Middle is the 2 rectifiers and voltage doubler essentially, and then this guy on the right is the final filter cap after the filter choke. So that will be the B+ distribution point for the entire set. That's the one I don't have hooked up to anything right now. So that used to be a cap that was down here. So, where is the main B plus distribution? Well, it's in a few places. There's one point there, and it loops over, and there's another one, I do believe, there. And if we follow that, basically it's the red wires. If we follow the red wire around and around, it goes down to this lug with more wires branching out. One of those is a red wire going here, and that has an orange wire that snakes up, and that is the other side of the filter choke. So pretty darn convoluted. So in the original rectifier up there, voltage doubler cap over here, filter choke, final filter cap. Alright, so now that it's all been relocated over here, let's try to clean that up a little bit. So, out of the filter choke, we got an orange and a red wire. The red wire I've already got going right up there, and now I want to do the same with the orange wire. So, yeah, another bit of sacrilege. I cut it right there. And I'm going to peel it back and go up this way and put it in there. Another curious thing is with control here, outside leg of it should also go to B+. Well, right now it goes to this grayish wire, which goes down to here. So filter choke down here, and wire back up to the control right next to the filter choke. So when I put the filter choke wire over here, I'm also going to take that wire and disconnect it here. And then I'll run a wire from here down to this point. So to simplify the wiring a little bit, in other words. And then I need to tackle this. So we're down to only 3, because one of the filter caps was relocated over that way. Actually, 2 of them were. And now all that's left are 2 of these need to go to 22 microfarad caps that I'll relocate somewheres. And then that guy, one of these I've already taken care of, I do believe, over here. So I think I have 2 more left to do here. So what are we down to? I think there's 4 caps left to locate. The 2 22 microfarads and a 10 microfarad boost cap, and one other. Oh yeah, the filter cap on the 140 volt bus has to be relocated. I finished wiring up the little assembly, and yes, I did install 1000 picofarad ceramic caps across the diodes. Not actually technically across the diodes. They're from each diode's cathode band to ground. Put one on that side and one on the other side. Still have to dig up a screw to screw that down and find a 56K 2-watt resistor. Well, so that's the thing. I have plenty of 56K 2-watt resistors, but that's kind of huge. Probably really is 2-watt though. It's amazing how much smaller resistors have gotten. I was hoping to find a 3-watt, but if I can't, I'll go with a modern 2-watt equivalent. And here is my new red B+ wire feeding the entire set. I salvaged that from another chassis. I do have a dwindling supply of new wire, but since I don't seem to be able to get this anymore, I'll scavenge it when I can. I also wanted to point out that there are other places you could put these caps. For example, if you follow this, it goes over to this tie point. And right next to that, there is a ground connection, so you could put one of the filter caps in right there. Similarly, I think there are some other points. Perhaps this terminal strip could be used for something else. I mean to look it up in the service info. Couldn't quite. Well, it might be another change in production. So I'm pretty sure that is the boost voltage. 47K, and then over to the CRT. I don't see a 47K going to the CRT anyway. I figured what it was is, here's the boost cap going over, and they show it going directly. I believe J31 is that pin on the CRT. So perhaps there's a production change to add a 47K resistor in there somewhere. And that is one cap I have yet to figure out where to put. Now, if it wasn't for that 47K resistor, that'd be perfect. Put it right there. But with it being in circuit, not so much. Anyways, I'll figure that out. And I've got these to tie off somewhere. Two more electrolytics to go and I'm done with the recap. I finally found a place for the boost cap. For a moment I want to talk about vintage tube TV power supplies in general. They typically have three main voltages. There'll be your main B+ off the power supply. In this case it's 275. It feeds sweep circuits, audio output stage. And then there's typically a lower voltage. In this case, it's the 140 volt bus, and that typically powers the IF circuitry. And then there's usually a third one, which is your boosted voltage, in this case 400 volts. So where do you get 400 volts from when the highest output potential from the power supply is 275? They steal it from the flyback horizontal output transformer via the damper tube. Just think about it, you got an oscillating signal stepped up through a transformer driving the yoke, and you need a damper tube to kind of snap it back and get the good sawtooth action to sweep across and snap back for the next scan line. While we're rectifying that, why don't we pick some of it off and filter it and use it? So that's exactly what they do. They divide it down a bit through 100K, a 68K resistor, and then they filter it with that to get about 400 volts. So I had to figure out where to put that. Well, I found those two resistors. They're kind of oddly placed over here. There's a 68K and a 100K, and between the two, there goes the boost cap. And there's a ground terminal right next to it, so bam, done. That resistor I was wondering about over here, that is a later addition. It was done to protect the CRT. So the other thing that the boost voltage typically goes to is G2 on the picture tube. That's one of the accelerating anodes in the electron gun. So that's why I couldn't put it quite in over here. It's a little bit odd though, is the damper tube is over here, and then they run a wire all the way from damper tube over to here, and then divide it down a little bit, filter it, and then over here, and then into the picture tube, and there's a wire somewhere, I think. Well, I don't know exactly where it is, but it goes to the vertical output circuit. Alright, so that leaves, well, one tricky one left. This guy. Well, not so much the cap. So that is this guy. So I talked about in an earlier segment about the decoupling caps. Well, here's the other one. And I could possibly put that on the main board. L28U, that's going to the audio output. There's space on the board, I can mount that cap there. Problem is, where the heck do I stick R11, the 1K resistor? That used to go from this, which is the 275 volt bus. Then there was a 1K resistor right to the filter cap that was in here, and they used the lug, in other words, as a terminal strip. That lug's gone, so now I got a 1K resistor floating around in space. Kind of a drag. And there are no unused lugs that I can find. If I have to, there is a hole right here. I can mount a terminal strip just for one resistor. Kind of stinks. I'm still exploring my options. So I just need a 1K resistor from B+ to a wire. If I can find B+, which is also over here, and there. If I can find an unused lug on any of these terminal strips, B plus is also right there. There was just an unused lug somewhere near B plus. I could throw the 1K resistor in there and then route a wire over. But I do not see any. Okay, that I do believe is everything, except for a little final cleanup, but I'll wait on that till I get the set operating. By that I mean there are a couple places like this where I cut off the lug of the capacitor because it's been rerouted elsewhere, and I need to replace the wiring. For now I'll tape it up temporarily. Same with over here. Did end up having to install one terminal strip. Just couldn't find a place to put that 47K resistor and the 1K decoupling resistor, but it also meant that that gave me a place to put the final 22 microfarad cap. Now I actually ended up putting in 2 extra electrolytics. So this red wire that goes all over is the main B+. The main filter cap for that is this guy down below. Well, originally it was over here, and this is a major distribution point to a lot of other circuitry. So I thought, what the heck? There's a ground lug right next to it, so I tacked in another 22 microfarad cap there. And another cap that had been up here served as decoupling for something on the main board and for the tuner. Now I did relocate it over here, but I thought, since it's also used for circuitry way over here, let's put another one in. So that one will be on the board. Up over there. Yeah, I do still want to replace these thermistors and that resistor, but I'm kind of itching to get this thing powered up. So I think that's enough work underneath, other than, of course, I want to wrap some electrical tape around this and this. I want to flip this over and then put that board in. I do believe it's ready for installation. I've checked and rechecked everything. Every resistor's been replaced, all the paper caps. Some say that that mica cap should be replaced. I have never found one of this more modern style to go bad, so I just left it in. Ditto goes for the ceramic caps. I did check continuity and the handful of inductors up here. They seem to be okay. The sockets that I did not replace, I visually inspected. They seem to be okay. So I'm going to flip this over, pop that board back in, and then the fun begins of re-hooking up the wires. The main board has been reinstalled and rewired, and I populated all the tubes. These are all originally Philco branded, as near as I could tell, except for that 12DQ6, which I could not find. It's actually a 12CU6, but same filament pinout, so it'll at least be enough so I can test the filament glow. I didn't test any of these tubes. I figured that'd be part of the fun of getting this thing up and running, but I like the fact that they were all original Philco tubes. So what I want to try doing is power this up with no fusible resistor, so no B+. It's just going to have filaments on all the tubes and the dial lights. Don't have the picture tube plugged in, so I stuck this dummy load in there. Actually, it's not quite right because it's a 750 ohm resistor. I have a lower ohmage dummy filament load resistor somewhere, but I couldn't find it. So 750 is way too high. It should be more like 8 ohms. So I just jumped it out. So essentially that's 0 ohms. But that'll be enough to get filament continuity. In other words, all these tubes are in series. Without the picture tube being plugged in, it breaks the chain, nothing will light up. So I'm essentially just shorting that out. Alright, I did check the power switch. It does appear to be good. I left it in the turned on position plugged into my trusty PR57. Set for current monitoring mode. So without further ado, let's fire this puppy up. Current shut up to about 1 amp. It's dropping. Should settle in around 0.6 amps if everything is working right. I see we have tube glowage, and we are settling in right about 0.6 amps. And I can smell the smell of roasting thermistor and power resistor. When thermistors especially are brand new, they have a kind of a characteristic burning electronic smell when they get hot. It does fade with time. Same goes for power resistors. But we are holding steady. It settled down to about 0.5 amps. Let's check what our line voltage is. Right about 117. Alright. Now remember, one of my resistors is bigger than it should be, so that's going to limit the current a little bit. But more importantly, the main pilot light isn't lit. Remember, we went through and analyzed it. Part of the current flow for all the tubes goes through that dial light. With it being burned out, this is exactly what I was getting at. The set will keep working at somewhat diminished current flow. So if I get that light running, the current draw should go up and the tube should get a little bit brighter. And here's the UHF. I just changed the channel selector, and hey, it lit up. So that must be the UHF position. So let's count down. So UHF, and then there should be 12 positions with no UHF. So that's 1. Let's just count them out by channels. So I guess that'd be channel 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. UHF, it's back on. Cool. This is not the right knob, I believe. This has 2 through 13 and no U. I gotta look back through my original video and photos. I can't remember if this set had the original channel knob or not, and if it even had the U on it. This is my first holiday set with UHF, so I'm not sure exactly if there was a U position on it, or was it just that blank position on the channel knob. Anyways, what's up with this bulb? Hey, what do you know? It's not burned out. It just wasn't seated very well. Boy, that is pretty bright. And our current draw has gone up. Not quite 0.6 amps, even though I went from 0.5 to 0.5 I might have crept up a little bit more, so almost at 0.6. And I think the tubes are glowing just slightly brighter. So cool. That is one major piece of the puzzle. Also notice that the original light shroud is gone. I heard that was a common issue with these. There should be a cardboard tube over that. Somebody just wrapped some masking tape, which is disintegrating. Also, you can see these controls over here are horribly dirty. I haven't done anything in this area yet. I may unmount the tuner and give it a bath. Same with the controls. It's all pretty grimy. But hey, how about that? After all that work. Alright, I'm going to take a break for now. It's in the wee hours, and I don't want to do anything stupid. So there's 2 things I want to check next. One, hook up a speaker and get B+ and see if we can hear any crackling out of it, maybe even receive something. And then get out the picture tube and hook up the yoke and the CRT plug. I'll do a little research. Oh, wow. Something let loose. That was pretty dramatic. Kind of curious what it was because all the tubes are still lit and their current draw didn't change. Wow. Cool. My best guess would be the across the line capacitor, actually, even though it's a type safety cap. Although I think it's located more on this side. Wow. Glad I got that on film. So, what the heck? Doesn't smell too horrible. But without that being in there, there's like no B+, so there's not a whole lot going on. I can't imagine what the heck is over underneath the IF section that could... Oh wow, that cap blew its top. Huh. That's pretty freaky. I wonder how in the world... Oh man, the only thing that makes any sense, so one side is just going to ground, which is the chassis. And this other side is going to, through a 1K resistor to B+. Huh. I wonder, could I have put, no, I couldn't have. I was thinking maybe the fusible resistor, I got both wires on one side and wasn't doing anything, but no, there's AC in, and then here's the wire going to the power supply. With nothing inserted in there, there can't be any power, there can't be any voltage on that cap. What the heck? Well, that's going to be an interesting little puzzle to figure out, but I'm way too tired to do it now, but... Huh, I can't remember the last time I had a capacitor vent on me before. Sure as heck not one when I disabled the B+. Alright, well, excitement abounds. Well, we will pick up, I guess, in the next installment when I, well, try to figure that one out.